Hello everyone. Now we will see the next point, that is the enzyme kinetics. Under the enzyme kinetics, we will study the two equations or the two plots. First, Michaelis Mention plot. Second, Lineweaver-Burke plot. Now the first is Michaelis Mention plot. So see, we will study it under the 10 points, which is simple for you. So see the first one. The Michaelis and the Menton in 1913 proposed an explanation for the effect of the substrate concentration on the enzyme activity. So see, the 2 points are important: substrate concentration and enzyme activity. Now the second point is that according to this, the Michaelis Mention given the mathematical relation between the substrate concentration and the velocity of reaction, means same substrate concentration and enzyme activity, or you may call velocity of reaction. Now the third point is that, so according to this, enzyme E, the substrate S, the both combines to form the enzyme substrate complex, and again it will break down slowly to form the product as shown here. So see in the equation, enzyme and substrate combines to form ES complex and it will break down to form enzyme and product. So K1 velocity constant of the ES, K2 dissociation constant of the enzyme substrate complex. Now fourth point is that applying the law of mass action to the equation 1. So apply the law of mass action to this equation 1. How? See, the K1 E and S, for K1 this enzyme and substrate is taken and it will show the rate of forward reaction, and K2 here taking the enzyme substrate complex, that is the rate of backward reaction. So at the equilibrium the rate of two reactions are equal. So at the equilibrium the rate of forward and backward reaction will be the equal. So the K1 enzyme substrate is equal to K2 enzyme and substrate complex. Okay, now moving, so this is our second equation. Now moving towards, divide the both side by Ks. So whatever may be your the second equation, you should divide its both sides with the enzyme substrate with the rate of forward reaction. So see, as I make here the marking, you will get the finally enzyme substrate and enzyme substrate complex K2 K1 is equal to the Km, that is the Michaelis constant as I shown. This is the equation third. Next fifth point is that if E0 is the concentration of the total enzyme, then enzyme plus enzyme substrate complex is equal to the E0, and at the last we will have the value of ES. So after this equation there is a list of intermediate product and we will get at the final ES is equal to E0 S Km plus S, that is our the equation fourth. Next the sixth point, thus the velocity V of overall reaction is given by V is equal to K3 in bracket enzyme substrate bracket close. Okay, so put the value of ES from equation 4 we will get. So see the equation 3. So here given that, put the value of ES from the equation 4 and we will get, so here as we are having the V is equal to K3 ES, so here we are putting this value. Okay, and next point is that according to the law of mass action, V is equal to Vmax. V or Vmax is equal to K3 E0. Okay, so as per the law of mass of action, so put the value of K3 E0 in equation 5. So we will see here in equation 5 we will put the value of this K3 E0. So equation 5 is here, V is equal to, in place of this K3 E0 we have to put the V. So here K3 E0 means V S Km plus S. That is the equation 6. This is equation is the Michaelis Mention equation. When V is equal to half of the maximum velocity. So this V is nothing but the half of this maximum velocity, which is the important point. Next, so put this value in equation 6. So once again we are putting this value in the equation 6. So what we will get? So in place of the V, we have to put V max by 2 is equal to V max S divided by Km plus S, or the final equation is 2S Km plus S, and finally we will get the S, that is substrate is equal to Km. Okay, so these two important equations on the basis of which we will focus on overall the Michaelis Mention equation. So thus Michaelis Mention constant Km may be defined as the concentration of the substrate. So this Km is nothing but the Michaelis Mention constant, which is defined as the concentration of the substrate. So how this concentration of the substrate? It is the initial rate is half the maximum rate. So the initial half of the maximum rate. Okay. So Vmax or V, it is the maximum velocity of enzyme reaction. So these 2 points are important. Michaelis Mention, it depends on the concentration of the substrate, and it should be the half of the maximum velocity. And the last point, 10th, is the Michaelis constant may be determined by a plot which is commonly known as Michaelis plot. So see the plot here as I shown. Here the rate of velocity V, substrate concentration. So we are getting here Michaelis constants. How? By taking the Vmax half of the velocity, half of the maximum velocity. So these are the total 10 points which are useful for the study of Michaelis Mention plot. Thank you. Remaining the linear Burke plot we will see in the next video.